Hello, hello. We're back. In this video, we're going to be working through this little sample test, comparing fractions, decimals, and percents, and uh, looking at some percent problems. Number one, so I want to compare 5/8 and 7/12, and I need to fill in my square with either less than, greater than, or equal to make this comparison true. Want to compare fractions. Eights are not the same size as 12s. Remember, the bottom number tells you the number of equal sized parts in the whole. Equal sized parts, that's key. Equal sized parts in the whole. So in this case, what it's saying, if I have a pizza that's divided into 8 equal slices. This is saying a pizza divided into 12 equal slices. And I think we agree in pizza divided in 8 equal slices. Each slice is going to be a different size of this. So we have to make each denominator the same. That means we have to find something that's a multiple of 8 and 12 that's common. Oops. Can't seem to copy things down accurately here. And I know that I can divide 24 by 8, and I can also divide 12 by, or 24 by 12. So 24 is a common denominator, so that means I would have to multiply 8 by 3, 5 by 3. Let's get to 24, I'd have to multiply by 2, and I'd have to multiply the 7 by 2. Remember, this works because 2 over 2 is 2 divided by 2, and this right here equals 1. Right, that's the same as 1. So let's finish off. So 5 times 3 is 15. 8 times 3 is 24. 7 times 2 is 14. 12 times 2 is 24. And I can see that 15 24ths is greater than 14 24ths. That's when I read this way. So, because this is my greater side, but it still makes sense even reading this way, because I come to the smaller side first. So 14 is less than 15 24ths. So 5/8 is greater than 7/12, but not by much. Number 2. Again, we're going to fill in less than, greater than, or equals to make this comparison true. But now I'm comparing a fraction with a decimal. So I have to either make the fraction look like a decimal, or I have to make the decimal look like a fraction. Let's set this up and see if we can do a side-by-side comparison. I'm going to change the decimal into a fraction first here. So that means I don't have to do anything at 5/7. And 7 tenths is, that's how I say this, so I'll just write the fraction, 7 tenths. But now I do have to do 7 because these have different denominators. Because 7's a prime, the smallest multiple is just going to be, I'm going to have to multiply both of these together to find my common denominator. So I'm going to multiply this by 10, and I'll have to multiply this by 7. So let's finish it off. That means I have to multiply this top by 10, and I have to multiply this top here, this numerator by 7. And that'll give me a denominator of 70. And that'll give me a denominator of 70. So 7 times 10 is 70. 10 times 7 is 70. 5 times 10 is 50. 7 times 7 is 49. So I can see that 50 70ths is going to be greater than 49 70ths. So that worked. So that tells me that 5/7 is greater than 7 tenths. But let's check the other way. Let's make the fraction look like a decimal. So a fraction is a division point. You know, that is such a big deal. I'm going to write that. A fraction is a division problem. Specifically, it's the top, the numerator, divided by the bottom, the denominator. So what do I have here? I have 5 divided by 7. How many 7s? Just as a reminder, remember I'm going to first divide, then I'm going to multiply, then I'm going to subtract, then I'm going to bring down. So let's divide. How many 7s can I get out of 5? I get 0, because there's no, I can't get any 7s out of 5. None would be 0, so I get 0. So what that means is I have to break 5 apart into smaller pieces. And so what I'm going to do is I will break it into tenths by putting down a decimal, bringing up the decimal, and adding a 0. So now I have 50 tenths. Well, now I can divide 7 into 50. How many 7s go into 50? Well, 7. So there's my divide. Now I multiply. 7 times 7 is 49. I will subtract 50 minus 49 is 1. And I can't make my comparison yet because look, there's these two match. So let's add another 0 and bring it down. How many 7s can I get out of 10? Well, I can get 1. 1 times 7 is 7. There's 3. But I notice I'm at a point now that I actually can make my comparison. So 5 7s is the same as 0 and 71 hundredths, and it looks like it keeps going. So we haven't really ended this problem, but we've gotten far enough where we can make a comparison. And that's going to be enough to compare it to 7 tenths because 7 tenths is the same as 70 hundredths. And I could see that 71 hundredths is greater than 70 hundredths, which again means that 5 7ths is greater than 7 tenths. Let me go like this. Let me box my two answers. Next up is, again, fill in with less than, greater than, or equal to make the comparison true. So I have 11 and 2/9, and I'm comparing that with 11 and 4/15. Well, conveniently, the whole number in front of here is the same, so I'm not even going to worry myself about the whole number part. I'm just going to look at the fraction part. And I'm going to say, so I'm going to compare 2/9 and 4/5. So this is going to be like problem number 1. What number can I divide by both 9 and 15? Well, another thing I could do if I'm not sure is I can make myself a list of multiples. So if I do 9s, I'll do 9s. I'm going to write them up and down. So there's 9, 18, 27, 36, 45, 54. Let me do the 15s here. So there's 15, 30, 45. Oh, hey, there you go. 45 is a common denominator. So that means I can take 2/9 and 11 and 4/15. So 9 times 5, 1, 2, 3, 4, 5. No, it's the 5th multiple. Will get me 45. If I multiply the bottom, I also must multiply the top. With 15s, it's the 1, 2/3 multiple, so I have to multiply it by 3, top and bottom. And when I do that, I get 10 45ths for 2/9, and I get 12 45ths for 4/15. And I can see now that 10 45ths is less than 12 45ths. Or the other way to think, 12 45ths is greater than 10 45ths, which means that I need to go like that. We'll do one more and we'll take a pause. So now I'm comparing a fraction with a percent. So again, I have to put things in the same form in order to compare them. I'm going to start by putting the percent into a fraction. So percent out of 100. So this becomes 80. 80% is the same as 80 over 100. Now, so what I'm going to compare is I want to compare 6/7 with 80/100. Now, something that's always true, that's helpful, is if you can reduce before you do your computing or your comparisons, you often make work a lot easier for you. So I'm going to reduce 80/100 first. So 80/100, I say I've got a 0 top and bottom. So that means I can cancel both the zeros. Why does that work? Because 80 is the same as 8 times 10, and 100 is the same as 10 times 10. So there's a 1, 10 over 10 is 1. So 80/100 is the same as 8/10. But look, I can divide both 8 and 10 by 2. So 8/10 is also equal to 4/5. Oh, I like that much better. So I'm going to compare 6/7 and 4/5. These are both prime, so I'm going to have to simply multiply one by the other. So I'll multiply the 7 by the 5. I'll multiply the 5 by the 7, and then I'll have to do this, multiply by the same value on top for each fraction. Because remember, 5 over 5 is 1. 7 over 7 is 1. So I'm not changing a number, I'm just rewriting it into a different representation. So this becomes 30/35, where this becomes 28/35. And now I can see that 30/35 is greater than 28/35. If we were just to change this to a percent, if we would change the percent to a decimal, remember, changing a percent to a decimal, the shortcut is simply realizing that where's my decimal value when when it's not written? Well, it's right here. And to go from percent to decimal, I just have to shift my decimal point over twice. That's the shortcut. So that means I have 6/7, and I'm comparing it to 0 and 8/10, right? So it's right here, I went once, twice. So now the decimal point's right in front of the 8, to the left of 8. Now let's change, I'll change the 6/7 into a decimal. That means I have 6, and I'm going to divide it by 7. I get 0/7 out of 6, so that means I have to break the 6 up into smaller pieces by adding decimal point and a 0 there, so now I have 60/10. 7 goes into 68 times. 8, so that's my divide. Next is my multiply. 8 times 7 is 56. Now I subtract. 60 minus 56 is 4. I have to add another 0 and bring it down. How many 7s go into 40? 5. Right? And 5 times 7 is 35. And it will keep going, but I'm at a point now where I can stop. Because if I look here, I see that 6/7 is the same as 0 and 85/100. And it keeps going. So this is not the end of it. But that's enough to compare it to 8/10, because 8/10 is the same as 0 and 80/100. And again, we can see that 85/100 is greater than 80/100, which means that 6/7 is greater than 80%. I'm going to stop this particular video right here and pick it up just because we're already getting longer than I'd like.